screen. Share the screen. Still we are working on pressure vessel. And one thing, it is time to give a quiz. Okay. So I forgot, I should post in the classroom that what will be our syllabus for the first quiz. So what about the column? Or I can give you the torsion. Which one you want as a quiz? Torsion, column, or both chapter? Hello? You might don't know that what immediate, or you might be not listening to me. Anyway, I will decide then that there will be two chapters for the quiz, column, and the torsion, and I will post in the classroom. Anyway, we need to start our class on pressure vessel. So far, we finished this much in the last class. Excuse me. If you pressurize a pressure vessel, either it might be a cylindrical shape or it might be a spherical shape. So there are three stress developed in the pressure vessel wall. Number one is tangential. It has other name. It's called hoop stress. Other one, radial stress, and third one, longitudinal stress. So three stress developed in the pressure vessel. If any of these stress become higher than yield strength of the material, then what will happen? It will burst. For example, you make a pressure vessel with aluminum. Now we say in aluminum, for example, SecB YT, tensile yield strength, say 63 KSI. And ultimate strength, tensile strength, say, for example, 70 KSI. Now, you have a pressure vessel, you calculate the stress of that pressure vessel, and by calculation, you found that sigma T of the pressure vessel, tensile strength, sigma T, this stress equal to coming 73 KSI, then what will happen? Is more than ultimate strength. That means it will burst immediately. It will fail. And if you say your tensile stress due to the pressure coming 68 KSI, then what will happen? It might don't burst, but if we have the permanent deformation, it will not come back in previous position. For example, we use pressure vessel in our car. So when you pressurize, say your tank is full, normally in the pressure vessel we use in the car, all the gas station, they don't have that much pressure. Because say this is your pressure vessel, tank in your car, and right over here is the gas reservoir. You go to the gas station, this is the pipeline, they might have a compressor over here, then they have a station. So from the compressor, your gas is coming to the station, and with a tube, you are getting in your cylinder, right? So this compressor pressurize, say sending the gas to the refill station in 150 KSI. Okay. 1 second, please. Is sending with 150 KSI. So initially is going inside your cylinder with 150 psi, right? Then gradually become it full, inside pressure increase, say is coming 148, then what will happen? Your flow will be gradually reduced. When it becomes same pressure of 150, then your gas flow will stop. You might say my gas cylinder is full, but actually it might be not full. If this is compressor is too strong, say it create 200 psi pressure, then inside cylinder you might be able to fill up until 190. So it will have more pressure inside. So what I'm saying, when you fill up the tank, then what happened? Inside, due to the pressure, say you buy birthday balloon, you put some air by your mouth, it expands. Why expand? Due to the fluid pressure at the wall of the balloon. So same thing, this is a kind of balloon, but instead of the wall is material, not the rubber, not the super elastic, right? So this material, when you fill up, then diameter is increased little bit. That means it is expand. Inside diameter of the cylinder is increased. That means size of the cylinder is increased. But you will not able to see on your own eye because your diameter might be increased by 0.005 inch. So you cannot realize in your eye. Okay, after you run about a week, your gas, there is no pressure in the gas. All the gas is empty, you burn it. Then what will happen? Inside the pressure is 0, but outside pressure is atmospheric pressure. As a result, your cylinder will come back in previous shape. Then again you refill, your cylinder will be expanded. Then you burn all the cylinder, then your cylinder will be again your shrink. So one time cylinder shrink, one time it is expand. Excuse me. Okay. So what I like to say, when you refill your gas cylinder, it will expand, volume will increase. When you burn all the gases, then volume will decrease. So on time volume increasing, on time volume decreasing. Like seems like it works like a spring. Okay. So still, when you refill the gas or you pressurize a boiler, there will be these three stress: sigma L, sigma R, sigma T. Now, there is a name over there: radial stress, tangential stress, longitudinal stress. But you need to know that what is tangential stress, what is radial stress. You know that in the beam, there will be bending stress sigma equal to MC over I. Sigma equal to MC over I. This is on stress. Other thing, tau equal to VQ by IV. This is also shear stress in the beam. So similarly, in the cylinder pressure vessel, there is three stress. But you need to know how these three develop and how we can physically you can understand that what is sigma L, what is the effect of sigma L, what is the radial stress, and what is the sigma T. So let's see. This one a little bit bigger picture of previous slide. So right over here is the slide. In this slide, actually what happening, this one I make it bigger right over here. Say you have a plate. You have a plate, say certain it has thickness. For example, 3-inch thickness aluminum plate you are taking. And you make a hole in the plate. You make a hole in the plate, this much hole, and you try to put a rivet there. If a rivet diameter is less than the diameter of the hole, then what will happen? It will easily enter in the hole, right? But if the rivet is a little bit oversized, then what happens? You cannot put it easily. You need to hammer it a little bit. Okay, so you hammer it a little bit, then your rivet, due to the hammering, try to push the material along radial direction, along this direction, right? So if the rivet or bolt is pressing the hole in radial direction, that means it will create some pressure. And due to this pressure, what will happen in the material, in the plate? What will be the possibility? Number one possibility, that diameter of this hole will increase. The diameter becomes a little bit bigger. What does it mean? That somebody pushing the wall of the hole in radial direction. So in that direction, some stress is working. That stress, I'll call it sigma R. That means radial stress will develop. And this one, say you have a 3-inch hole, 3-inch thick plate, and you're putting a bush or you're putting a rivet and hammering. What does it mean? This 3-inch long hole, and say hole diameter is 2 inches, for example. And you are using a rivet or a shaft diameter 0.02 inches, little bit bigger. So you cannot easily enter if you are hammering. Then what will happen? This hole will work like a pressure because he will experience a pressure at the wall. Then what is the possibility? The diameter of the hole will be bigger because in radial direction at the wall something is pushing. So there will be sigma R. This is called radial stress in the pressure test. Other thing, that this material might be cracked like over here. Right? This person. Why there will be cracked? What is the reason? Cracked means there is some kind of gap. Gap might be 0.001 millimeter, 0.0001 millimeter. Or this gap or crack you might be seeing in your eye. So crack mean I'm saying it creates some gap in the material. What does it mean? It creating some gap in the material. That means this material, somebody pulling along this direction, somebody pulling this direction. Then it creates a gap or crack. Otherwise, how crack is developed? Obviously, somebody pulling along this direction. So this stress is working actually along tangent of the hole along this direction. This is called tangential stress or sigma T. Sometimes it is called hoop stress. Sigma T. Some book write down it is sigma theta. So you look over here. If I take some material from this side over here, this I like to look this material, that how many stress is working in this material. This material I pull it right over here. So I know that there is a possibility that somebody pushing to make the radius bigger. So this material right over here will feel a compressive stress, right? Feel a push along radial direction. So if you take some material from here and you try to look his free body, then it's the free body coming like that. So this is the material. That means some stress will work along radial direction. That is called sigma r. And some stress will work along tangential direction. That means if I say if there is a crack developed in the material, if I okay this one is crack developed, what does it mean? Somebody pulling this material along this direction, somebody pulling it along this direction. And this two line is tangent right over here. So along tangential direction, there will be a stress on stress working along this direction. So obviously, right over here is pushing along radial this direction. Then this will move, right? But we are working stationary body. That means there is static body. There is no movement of the body. So this will be sigma r. In this material, at the outward direction, stress working sigma r. At inward direction, also stress will work sigma r. That means radial stress. So that stress working where? I am imagine a small segment of material taking from here, and that one is showing over here in that free body. So you got some idea that what is sigma r, and then I tried to show you that what is sigma theta. So or sigma t. So along tangential direction, whatever stress is what, that is called hoop stress. Some book write down sigma t, some book write down sigma theta. So in this picture is showing sigma theta all in tangential direction. So obviously right over here will work sigma theta. So two stress you understand that what is sigma r, then you understand what is sigma t, or you can say what is sigma theta. Sigma t and sigma theta is same, right? Now, what is the other possibility? Anyone? What is the other possibility? Who can tell me? Anyone? No. Other possibility, this plate might, what happened? This is work like a cylinder, this hole, right? What is the thickness of the plate? 3 inches. So you can say if this hole, if you look from the side, you can say this hole is 3 inch long hole. And what is the diameter? I can say the diameter, but it has obviously the certain diameter, right? But this length from here to here will be 3 inches because the plate thickness is 3 inches. Now, if you hammer it, there is a possibility that this plate break down in along the thickness. That means this cylinder might be become in 2 parts. That means that stress is what if I say the hole is this one. So radial stress is working along radial direction, along this direction. Tangential stress, if I take a cross section of this one, then your tangential stress will work along this direction, along tangent of this circle, right over here along this direction. Now, there is a possibility you are hammering from this side. For example, you are hammering from this side. Possibility that this plate just become in 2 parts. Just it break down at the middle or anywhere, but it became 2 parts. So how is this hole become 2 hole? That means 1 cylinder become 2 cylinder. What is the possibility? Possibility is that somebody might be pulling along this direction and somebody pulling along this direction. Finally, it becomes 2 parts. 1 cylinder becoming 2 cylinder. That is called longitudinal stress. That means working along length of the pressure vessel. This is called longitudinal stress. So now you got the idea of sigma T. You got idea of sigma R. You got idea of sigma. Just I give you the concept that how sigma R, sigma T, sigma L is coming. Now I'll tell you the what is their effect. I already tell you a little bit, but we'll show you more over here. Then we need to figure out that what will be the formula to find the sigma T, value of sigma T, to find the sigma L, to find the sigma R. That we need to. Okay. So far, any question, anyone? Hello?
No, sir.
No question. Okay. Other thing, that how we can distinguish between thick wall and thin wall. Right over here is some formula right over here. Right over here is the formula. If Ri, internal radius of the cylinder, is less than 10 times of wall thickness, then it is called thick wall. If internal radius of the wall of the pressure vessel is greater than 10 T, then it is called thin wall pressure vessel. So right over here, I got a mistake. There should not be T over here. Okay, this is thin wall and upper one thick wall. But in solid mechanics class, we will teach you only thin wall pressure vessel, not the thick wall. And thick wall pressure vessel will study in the machine design. Okay, in your 3-2 semester. Okay, now you see the effect, how the sigma R, sigma T is working. So sigma T is working along length of the pressure vessel. We just take some peripheral part of the pressure vessel and is showing how sigma L, sigma T, sigma R is working. So this is sigma L, and along tangential direction is working sigma T. And in radial direction, you see working sigma R. So you see somebody pulling toward left with blue color sign, sigma L. Somebody pulling toward right with sigma L. So what might be possibility? Possibility that this pressure vessel, part of the pressure vessel might be cracked right over here. That means it becomes two parts. The longitudinal stress. What is the effect of radial stress? Is radius might be gradually increased because it's pushing radially. And tangential stress, what will happen? He is pulling along this direction, also this one pulling along this direction, right? In this case, there might be cracked developed along length of the pressure vessel. So if we see some picture right over here, it's showing how the sigma T and sigma L is working. Sigma R is working in radial direction, but right over here, we are just showing that say you have a gas cylinder, you take a chunk of material from the wall and you would like to check it, that how is the stress. Right over here, this is working along length of the pressure vessel. So this is sigma L. That you got this one, sigma L. Along this direction, sigma T, this direction working, tangential direction, this is working sigma T. Now you might say, what is the sigma R in wall or in the right over here? This is sigma R. But in our solid mechanics class, we normally talk about thin wall pressure vessel, right? TP. So in thin wall pressure vessel, sigma R and sigma T, sigma R and sigma T, this both is almost equal, little bit variation. So if a pressure vessel is thin wall pressure vessel, then we can say sigma T and sigma R is almost same. Then in thin wall pressure vessel, there is only two things. Number one is sigma T and sigma R. Okay. So we need to have a formula that how we can figure out the value of sigma T and also value of sigma L. I turn on the video to show you the something coming. Let's see. Now we can see a little bit, I think. You see a note, right? I just roll it to make the pressure vessel. This is a pressure vessel. So what happened? If say the end cap, both have a cap at the end, it's closed. It's a pipe, right? So due to the longitudinal stress, this pipe might become two pipe, or this cylinder become two cylinder. And for tangential stress, it might become half right over here. Okay. And for radial stress, the radius or diameter of this pressure vessel might be increased. But we are talking about only thin wall pressure vessel. In that case, we will have only two stress, sigma T and sigma R. So right over here, you see a cross section of a pressure vessel. So this pressure vessel has inside pressure is P is working. And if you cut it like that, you take the half. So you're taking half, this is P working, and pressure. Even the cylinder surface is curved, but pressure always work perpendicular to the surface. So this is sigma T, this is sigma T, and sigma L will work right over here. If you took some material from the surface of the cylinder, then you make the free body. Say I am making a rectangular skin, I'll say skin or part from the over here. So this is, is showing, I'm showing straight. Actually this is not straight, little bit curved, right over here is showing a little bit curved, right? So in that case, along this direction will work sigma L. What will be other direction? Same thing, sigma L. So both are pulling. That means it will remain the same position. And there is a sigma T working along this direction, this working along this direction. You see along longitudinal direction, he is pulling right and he is pulling toward left. So if they pull with too much force, then this material will have a crack. That's right over here. It will crack right over here, along this direction. Similarly, if sigma T become very high, then it will develop crack along right over here. The crack will propagate. Actually, this make the split the cylinder along longitudinal direction. Okay. Right over here, that how cylinder might be failure due to tangential or hoop stress. Like you have a one cylinder, it just become two half cylinder, or it's showing only two half, right? But sometimes you see explosion in the boiler in a garments industry or in a rice mill. What did you see? The rice mill, it explode, 5 people killed, and you might get some part about 50 years part on the side, might be even 1 might far. Because due to the pressure, high pressure, this tangential stage, this one split in several parts along this direction. Similarly, in the bottom one, not only and material fly. Now, failure due to longitudinal stress, what will happen? Just one pipe or one cylinder just becomes at the middle, along longitudinal direction. Okay. So we need to have a formula for sigma t, and also need to have a formula for sigma l. So that we will do. Okay. So I am turn off the video now. See. Okay, now we'll derive a formula, sigma L and sigma T. Now, how we can derive? Sigma T is the tangential stress or hoop stress, and sigma L is the cylindrical stress or pressure vessel. So, consider a thin wall pressure, cylindrical pressure vessel. That is your assumption. And both end is closed. That means, like a pipe, both end is open, right? But gas cylinder, we use in the kitchen, we use in the car, both end is closed. It's a which is subject to uniform pressure P. Internal radius of the cylinder is R. Length of cylinder is L, and wall thickness is T. Now we need to derive a formula for sigma T and sigma L. Now how we can derive that two formula? Before that, we need to make some assumption. Number one thing, pressure vessel is made of homogeneous and isotropic material. Isotropic material of a Hooke's law. So the hoop stress, then you say our tangential stress, hoop stress, circumferential stress, tangential stress. All three stress is the same stress, same name. Normally, some book use as a hoop stress, some book use as a circumferential stress or tangential stress, but all the term are right. And sigma L is the longitudinal stress. And these two stress will figure out a formula to evaluate these two stress if geometry of the pressure vessel is given, material property is given. Geometry means length of the shaft given, wall thickness is given, internal radius is given, or outer radius is given, then you can use that formula to figure out the circumferential or tangential stress. Also, you can figure out the longitudinal stress, but without geometry, you cannot do anything. So for geometry, you need the analysis, you need the length of the pressure vessel, you need internal radius of the pressure vessel, you also need the wall thickness of the pressure vessel. And material property, is it made of value of E, you need to know. That is it made of steel or aluminum or something else. So from the material property, you will have value of E, you will have value of G, you have value of YT, right? With that value, you can figure out that it will not explode, or what will be the, how much your pressure cylinder is here, it's safe to use. What will be the maximum pressure you can apply in that pressure vessel? That you need to figure out. Okay, so we are considering a pressure vessel, radius, internal radius R, length is L, and wall thickness is T, and we are thinking material is homogeneous, isotropic. Then you can say material of the Hooke's law. Those three assumptions is almost same in all formula to derive the formula in the column, also in torsion. Now you see same formula we are using in pressure vessels. Not formula, same assumption. Okay. Now The free body of half of the cylinder is shown in the next slide. In the next slide, we look a figure that is half of the cylinder. So what actually happened? So you have I just looking a section view that this is the cylinder or pressure vessel, and inner one I was not able to make right this one right, so I can delete the outer. Okay, so right over here, what did you see from center to this one outer radius? Center to this distance inner radius, then if the difference you will get the value of the T. And at every point is pressure is working inside, working right over here, working right over here along this direction, working the bottom along this direction, also working along this direction, working along this direction. So all the pressure force working perpendicular to the surface. Now, so what does it mean? Is pushing. Due to the pressure force, cylinder will its diameter or size try to be increased, get to be increased. If you are use very weak material, say for your birthday balloon, you just put your ear by your mouth, is go bigger, you put more ear, actually it is fast. Same thing in the material. Say material able to take pressure 40,000. But any reason your pressure is extremely high, then material will be burst. Most of the boiler burst in the industry due to the safety valve is not working. Water level indicator. Say you have a boiler. In the boiler, if pressure is increased any reason, they use a valve that is called pressure relief valve. If inside pressure is going any reason going too high, then all the steam will get out through this valve. That is called pressure relief valve. They use to reduce the pressure inside. But sometimes a lot of people they don't maintain the pressure valve properly, or they might know that this one is not working. So that's why sometimes even pressure is increased. Say you have the pressure relief valve, you know that inside pressure is go 40 psi, then pressure valve will be open. Now most of the time you are running at pressure 360, for example, psi. Then you say I am fine. You just sitting in the monitoring or control room, looking to the screen, and you are sleeping. Okay, but any reason you are not sure that this pressure valve is working or not. So how will you know? If inside the pressure is this is 408, become at 408 higher than 360, the pressure valve will be open. So steam will get out and inside pressure will be come down. So we need to figure out that due to the pressure, what will be the value of sigma. Now in the right side, I take half of this pressure vessel. So I took half of the pressure vessel. You should see at the wall, right over here in the top half, what will be happen? The force is working along this all the surface. Along all the surface force is working. So if I think, if you consider only this force I'm considering. And I will split that force into two components, and how will be happen? If I take right color, red color, how much will be this angle? Say this angle will be theta. That's for example. So you will have this component, this pressure force, you can split into two components. So this will be, I'm saying, this is P or PF, pressure force. How will be this value? This value will be PF excuse me, PF into cos theta, right? And what will be the vertical component? PF
Sir, sin theta.
into sin theta. That I took only this force, right? Similarly, in the right side, for this one you will get PF, another PF, so this one say a pressure force working along this direction. So this one you can make two components. Same PF, one right side, other one will go at the top. This will be cos sin theta, right? Cos theta. This will be force into sin theta. Now, if you look a little bit carefully, you will see this force or this force and this force equal and opposite. So they will cancel out each other. So only force will remain in vertical direction. We say this one, this one. So similarly, if you take this force, it will have two components, one a horizontal component along this direction and vertical component upward direction. So at same level, you say that this one, then you see on force working along this direction, on force working along vertical direction. So how do you see that? You see now that these force are cancelling out. They are opposite. But these two forces working along vertical direction. That means all the pressure force, the resultant force of all the pressure force working only vertical direction. So if you work only vertical direction, then in this free body, I know that this will have two components. One will be work vertical direction, other one will be work horizontal direction. Similarly, this one will be horizontal, one will be vertical. So you see this will be cancel out with this one, but these two how will cancel out? These two will not cancel out. That means they are pushing upward direction. So you say your cylinder is good, is not you make with very good material, it able to carry high stress, then this sigma T material will resist along this direction. So if I draw it again, so I'm taking half of the cylinder. So all the resultant force will work along this direction, vertical. Then this cylinder will move up along vertical direction, right? But they attach together. What does it mean? That something pushing opposite direction. Something is pushing opposite direction. Now, if you draw the free body of bottom half, then what will happen? So some pressure will go work along this direction, downward, and right over here force will work upward. If you take the bottom part and upper part, so you see this force is the material resistance force. If this resistance force is less than this force, then what will happen? It will burst. But if this resistance is higher than this force, then your pressure vessel will survive. Okay. So how we can, and this resistance force is working along tangential direction. We are taking this half of the cylinder. We are thinking this force working downward, right over here. That means all the pressure force is working actually tangential direction of the cylinder. So that's why we show it on the right hand side, right over here. And this view, the right hand side, this view is taken if you look this one from this side. And this one I can increase the length little bit. I can say this is a bit longer. This one I can say. This one is a little bit longer. Okay. Then there will be thickness right about here. So this sigma t working all the way around in the bottom. So the thickness. So the thickness of it. That is showing right over here. Okay. So if I take a half of the, if I turn on the video, you see, I took a notebook, right? So right now I am talking of the half of the cylinder, right? Half cylinder. So what happened? All the pressure force, if you see like that, all the pressure force working along this direction, radially, upward direction, right? Half of the cylinder. But the wall metal resistance, this is the pressure vessel. I'm not able to hold it with one hand. Let me see if I have the smaller node. Like this one. I can hold it with smaller node. You see, so this one, all the pressure force working the surface and metal resistance working downward. Through the whole this area. What is this area? If length is L into the thickness T. Length L divided by into thickness. That will be this area. With this area working sigma T downward and pressure force working upward. So this pressure force is balanced by the metal resistance. That's sigma T. So how we can figure out the resistance force? What will be this area? L into T. This L into thickness. How will be this area? Same thing. L into T. And there is two areas, this area and this area. Area into sigma T, what are you getting? Force that working downward. And how much force working upward? How will figure out? Upward force, same thing, pressure into area. But how will figure out? You need to, there is one way you can do. You can take the projection area. If you look at the straight, then you need to project area will be rectangle. This mass will be length of the width of the rectangle and length will be L. Okay, but we'll figure out in another way. So let's see how we can figure out the pressure force tangential stress in the cylinder. Still we have time or time is over? Hello? Do we
So
have
the time is over.
Time is over.
over? Almost, or we have 3-4 minutes, 5 minutes over. Okay, let me just take 5 minutes, then we can finish. Okay, what I did in the previous slide, I'm showing the pressure, right? Over here, this is the T, thickness of the wall, sigma T working downward. I took a chunk of material, this chunk of material from the peripheral area of the wall. And I like to figure out how much force is working there. That one I try to show it right over here. And this material will be how much actually? If I'm taking right over here, it's all the way from here to here. If I say it's centered at the center from here, it making an angle. This angle, say this angle is theta, and radius of this cylinder is r. Then how much will be this length from here to here? How much? Anyone? Anyone tell me? R theta.
L.
R theta, right? This length. So how much will be this area? R theta into L, right? Just I finish this slide, then I'll keep it off. Okay. So what I did in this material, it making angle theta with the horizontal line. And this mesh angle is theta, d theta. So in this surface, everywhere pressure force is working. So right here, working, right? So I am saying the resultant force is dF, small force, because small area. So this dF, one component working horizontal direction. What will be that value? Is F into cos theta, horizontal component, and vertical component F into sin theta. That means we need to figure out P into area. Pressure we already know. Then how will figure out this area, this small area? This is outer surface. The whole surface is outer surface, but it has inner surface. So what will be inner surface? If you are able to figure out this length, small length of R, you can figure out the area. So length of R will be R into d theta, and length is L. So that will be the area. So R d theta is the width, L is the length, so you got the area. How much the force? P into L R theta. That means this is my area, P into area. Right? Now you see, if I take one more chunk in the left side, then what will happen? It will have one component work along vertical direction, other component will work along this direction. So this component will be same. If you take in the same side, we cancel out. You will have only this vertical component. Okay. So vertical component we put F into sin theta. What is the value of F? Right over here. P into L R d theta into sin theta. Now you can easily figure out the vertical force. How? If you just integrate this theta from 0 to 180, you are covering all the area. Then we can figure out the formula for tangential stress. So we just keep it right over here. Okay. So this much force working upward direction. What is the horizontal force? Downward force. What will be the bottom area? Bottom area will be thickness T, this thickness T into length of the cylinder. So length of the cylinder is L. Two area, right? One area is right over here, other area is right over here. You multiply by the two. Anyway, we will keep it over here and we will discuss it in the next class. Okay. Area that I was showing with this video, you look right over here at this area. This is sigma T work. Thickness T, length L. So my area will be L into T. You multiply by the stress, you will get the force. Then you will balance the force. Force working downward, you take algebraic summation plus force working upward equal to 0. From that formula, we'll figure out the sigma T that we did over here. Anyway, we are keeping over here and we will discuss it in the next class. So anyone has any question? Anyone?
Sir,
Yes, sir.
is there any limit for pressure? Like 408 psi, as you said.
Any limit?
Yes, sir.
That one I just say as a example, right? Okay, for giving a real world example. Say you are going home in a bus from Dhaka to Chittagong, and on the way in the restaurant you take food. But anyhow, the food is not bad, but it's a good restaurant. After eating your food, after 2 hours, you get stomach problem. That means your stomach is expanding. Okay, and you feel pain. Why? What is the reason? Because your internal organ is working like a pressure vessel, right? And due to the some gas form inside your stomach, and he's pressing outward, and his stomach getting bigger, and sometimes you see we have that kind of symptom, and you feel pressure, you feel pain, right? So if inside pressure is become very high, then what will happen? Your stomach will burst, right? So same
Yes, sir.
thing. Our stomach cannot take high pressure like you put pressure in the gas cylinder, because gas cylinder is made of steel, but our body made of a soft material with skin and muscle. Similarly, if you make a pressure vessel with titanium, very strong material, you can put more pressure inside. You got it? It depends
sir.
on which material you are using. You buy a birthday balloon, very weak material. You just put some pressure by your mouth, ear pressure, it getting expanded. But if we give you a glass bottle, say, okay, put your mouth and try to expand it. You cannot do it, right? Even
Yes, sir.
glass don't have the elasticity. But if you put extreme pressure, then what will happen? It's brittle material. Suddenly it will be explode due to the segment. Okay. So
Yes, sir.
next time we'll discuss it